Hey everybody, this is Mr. C, and today we are going to look at logic statements. The first type of logic statements we're going to look at are called compound statements. And we have two types here. We have conjunctions and we have disjunctions. And the way logic statements work is we typically have a hypothesis or a premises, something that we have seen, observed, and from that we draw some sort of conclusion. The same way with inductive reasoning, we see something happening and we draw conjecture from it. Okay, so logic statements work the same way. Here, they have given us a P and a Q, hence the P's and Q's. Okay, if we think of P as like our hypothesis or our premises, however you want to think about it, if we think of P as our hypothesis and we think of Q as like our conclusion, what we are going to get is a few different statements here. First off, just looking at the statements they gave me, we're going to discuss if they are already true or false. Vertical angles are congruent. If you haven't discussed this yet, or you haven't seen the angles yet, vertical angles typically happen when we have two lines intersecting, and the angles that are across from each other, these are vertical angles, and they are in fact congruent. This is a true statement. I'm just going to put a little T up here to tell me this is true. Okay, 15 is a prime number. Remember, to be prime means that only one and that number can go into itself. Okay, 15 is an odd number. 1 can go into 15. Sadly, 3 and 5 can also go into 15. So 15 is not a prime number. This is a false conclusion. Okay. With that being said, we are still going to write some conjunctions and disjunctions. They might not make a lot of sense, but I'm still going to show you how we write them and how we think about them. And sometimes our hypothesis and our conclusion might not necessarily seem like they go together, but we still write the statements and we can still evaluate them. So I'm going to start with the conjunction. A conjunction is written as P and Q. All right. Now, you see this little arrow or caret or however you want to refer to it, this little arrow that is pointing up, we think of that as and. Okay, so that is and. And what that means is whenever I discuss my hypothesis P and my conclusion Q, in order for this to be true, both P and Q have to be true. Both of these have to be true in a conjunction statement. So if I were to write this, I would start by writing my P. Vertical angles are congruent. Vertical angles are congruent. And then I would write my Q are congruent and 15 is a prime number. And that's the end of my conjunction. I've made the statement, vertical angles are congruent and 15 is a prime number. And the truth value depends on the hypothesis and the conclusion. So my hypothesis is true. Vertical angles are congruent. However, 15 as a prime number is false. So we can think of this as a true and a false. We need both of them to be true for it to be true, because we're talking about and, so it has to be both of them. So this is a false statement. and is including both of them together. That's why it's compound. They're compounded together. A disjunction, on the other hand, is or. And the way we say this is we can say P or Q. It kind of looks like a V. It's a little larger than that, but it is P or Q. So that is or, which means one of them has to be true, but not both of them. In the conjunction, both had to be. In a disjunction, only one of them has to be. So I would still write it the same way. I would still say vertical angles are congruent. Or 15 is a prime number. And remember, vertical angles are congruent. That is a true statement. Or 15 is a prime number. That is a false statement. But here we only need one of them for the whole thing to be true. So the truth value here is true because one of them is true. So conjunction requires both to be true. Disjunction requires only one of them to be true. Okay. So those are compound statements. The next type of statements that we are going to see are what we call conditional statements. Okay. Here we have a new hypothesis. It is St. Patrick's Day. And we have a new conclusion. It is March. All right. It's still very much in the same regard where we have a P and then a Q. The order is relevant. Okay. A symbol that we are going to see now that we have not seen yet will look kind of like a squiggly. This means not. Okay. We also call this a negation. All right. The first statement we're going to look at is called a conditional. And the way we write a conditional is we say P, I'm going to have this little arrow here to Q. And the way conditionals work is if P, and this arrow is kind of like saying then Q. Okay. And how I am going to write this is if it is St. Patrick's Day, so that is my P, if it is St. Patrick's Day, then, and now my Q, it is March. Okay. Then it is March. If you have not looked at a calendar recently or do not know the date for St. Patrick's Day, St. Patrick's Day is one day in March. I want to say it's the 17th. It might be the 15th, but it is definitely one of the days in March. So if it is St. Patrick's Day, then it is March. If you think about that, on St. Patrick's Day, that is a day in March. So this is a true statement. Okay, this is true. Okay. Conditional statements are, as they say, conditional. The condition that we are in matters. It is St. Patrick's Day. That is a day that is in March. So it being March is true. Okay. We have the inverse now. The inverse says not P, then not Q. It's the opposite. Remember, inverse is the opposite. So if it is not St. Patrick's Day, if it is not St. Patrick's Day, then it is not March. Okay. Now, think about it this way. If I say it's not St. Patrick's Day, okay, so it's not March 17th or March 15th. It's one of those 2 days. But if it's not that day, then it is not March, would be false, because there are other days in March that it could be. Okay? It could just be March 1st. March 1st is not St. Patrick's Day, but it is still part of March. So if it is not St. Patrick's Day, then it is not March, would be a false statement. Okay? That would be a false statement. We are thinking about the condition that we are in. It is not this specific day. That doesn't mean that it's not any other day in March. Okay? Now, a converse statement is the opposite direction. We're reversing it here a little bit. We're saying if Q, then P. If it is March, that's Q, then it is St. Patrick's Day. So if you think about that, if it is March, remember there are 31 days in March, then it is St. Patrick's Day. Not every day in March is St. Patrick's Day. So this truth value is false. You have to think about the statement being made and the condition it's being made in. So they are saying that if we are in the month of March, then it is definitely St. Patrick's Day. And that's false. Not every day is St. Patrick's Day. Okay? Not every day is St. Patrick's Day. Now we have contrapositives. Contrapositives are kind of like the inverse of the converse. If it is not Q, then it is not P. Okay? If it is not March, then it is not St. Patrick's Day. Cutting it close there. If it is not March, then it is not St. Patrick's Day. All right, well, St. Patrick's Day is a day in March. So if it's not March, then this is true because it can't be St. Patrick's Day. So this is a true statement. It could be May, it could be February, it could be April, it could be any other month. And St. Patrick's Day is only in March. So this is a true statement. If it's not March, then it's not St. Patrick's Day. And the last one, this is called biconditional. Biconditional means that we have to go both ways. It has to work with both. And the way we write that is P, and then we're going to have an arrow that points both ways to Q. And how we write this is if and only if and only if P then Q. If and only if it is St. Patrick's Day, then it is March. Okay. Now, the important takeaway here is it has to work both ways. So if and only if it is St. Patrick's Day, not any other day, only St. Patrick's Day, then it is March. Well, that's a false statement. And if I say it the other way around, if and only if it is March, then it is St. Patrick's Day. Again, there are other days in the month, so this is not necessarily true. We would say this is a false statement. Okay. Important things to note here, just as a quick recap. Our lovely arrows, if it is pointing up, it is and. That means it is both of them. Arrow down, or just one of them. It only has to be one of them. Okay? This symbol, this little squiggly line, means not. It is a negation, is negating whatever that is being said. Okay? And we think of it in terms of if and then. If P, then Q. That arrow means then. If not P, then not Q. If Q, then P. The order that we are writing these in is completely relevant. If not Q, then not P. If and only if P, then Q. And it has to be the other way too. If and only if Q, then P. So logic statements are always broken down into these either compound or conditional. There are multiple types of conditional. They always look at the order. It is the order that matters. Okay. You can think of conditional and inverse in the same order. P and Q, not P, not Q. And then converse and contrapositive in the same order. Q, then P. If not Q, then not P. Okay, so, and then biconditional both ways. Bi meaning two conditions. It has to meet both conditions. All right. I hope that this was helpful. If you have any questions, please don't hesitate to ask. And I want you to have a great day.